Hello, Angular Orange back with a tutorial. Today we're going to talk about ES6. ECMA script 6 is referred to as ES6. It's a JavaScript implementation. It can be used and transpiled into ES5, which is supported by all browsers. In addition, you could use polyfills to implement the functionality to support it. So you could look up browser ES6 compatibility at this URL and see where the browsers are and which features of ES6 are supported and which ones are not. You could also go to an ES6 playground and you can type in ES6 code and see its transpilation into ES5. And like I said in our previous tutorials, Angular, if you're coding in Angular, just use TypeScript. Get the IDE development environment to use Node 6 TypeScript version 2 and use Angular CLI with the IDE, and you're off and running. And right now, of course, TypeScript supports ES6. So if you're coding in TypeScript, you're using all the features, and it is kind of hard to distinguish which ones in ES6 and which ones in TypeScript, but I will go over that in our TypeScript tutorial. Oh, template literals. String interpolation, it's a syntax for embedding expressions into strings. For example, suppose you had a variable company name and you define it to be a string. You could actually log that string using the $ left curly bracket, variable name right curly bracket. So this syntax, what will happen is this expression would get evaluated and inserted into the resulting string. Now notice I'm using backticks here, so that's really important to understand. So the output, let's suppose you had a function. So the output of this particular code snippet would be welcome to angularorange.io. You could also call a function. Suppose you have a get company name and you return SWA Consulting Services. You could say welcome to and just do a $ left curly bracket, right curly bracket, and do the function name. And the function would get invoked and the expression would be evaluated and you'd output the string. Okay, we support multi-line strings using backticks. It's used to create multi-line strings that appear as they are written. So if I have a comment which has a backtick and I start breaking the line up and I end it with another backtick, if I go to log that comment, it would show exactly as it appears. And we use this quite a bit when we define templates, inline templates, let's say, and you just want to write a little snippet template. You use the backtick all the time, so you could format some HTML inside of your left tick, your backtick characters. Okay, tagged template strings. Template string preceded by a function name. A string is evaluated and passed to the function. String parts are passed as an array, and the expressions are evaluated as arguments. So suppose I had this function called total cost, and prices are first price and second price. What will happen is the function would get called and would pass the string parts into a variable called string parts, and then it would insert the first variable into the second argument, and then another variable into the third argument. So if you logged all these things, you'd basically see the string parts, prices are, and a period, which is this up here, and then you'd see first price and second price. And so within the function, you now have the ability to take these strings, take these values, maybe aggregate them, and create a sentence using the string parts and the values and the results. So for example, suppose we did have first price is $10, second price is $9.59. We could implement this total cost as the string parts and the first price and the second price. So the value 10 comes in this argument, the value 9.59 comes in this argument, and this argument is going to contain whatever's in the string parts. So it turns out that I construct this sentence and I say your item string part 0, first price, second price, so your string parts 2 is some $sign and then a total cost. Now notice I have the backticks here, and when I invoke the total cost function, I have string parts here. I have this element and this element, and so when I call this total cost on this function, I construct this sentence: your item prices are $10 and $9.59. Your total cost is $19.59. So notice I said your item string part 0, your item prices are first price, second price, so your total cost is, and then I just display the total cost. So feel free to use these if you need to. It's templates. Templates are templates. Okay, optional parameters and default values. Default values allowed in the argument signature. So you could have a function called calc_tax, which takes a price and a tax equals the 0.06. And the function can be called with one argument or two arguments. If it's called with one argument, the default value is 0.06. If it's called with two arguments, the default value is overridden. So in this case here, we have our total cost as the price plus the price times tax. So the tax could be 0.06 by default, or you can charge any other tax. So when you log both of these function calls, you'll get 106 and 109. Functions can yield default values. Okay, so what we're saying here is that you can have a function definition where the first parameter is price, the second parameter, or let's say the argument, is tax, and by default I'm going to call a function and default the value of that argument to the result of the function call. So if I have a get tax price and I return price times 0.06, then it's essentially the same effect I might have as the previous function. However, my function is implemented a little bit differently. So if I call this with two different prices, I get two different values. So we have scope of variables now. ES5, the var declaration, is always moved to the top of the scope, which can cause variable hoisting. The this keyword is also confusing. ES6 introduces a let keyword to solve variable hosting and arrow functions to cure the this keyword confusion. Okay, so here's variable hosting. You have a function which is called show value, and you have a for loop for int I equals 0, and I increments, and since the declaration int I is moved to the top and up to global scope, but the initialization is not, after the loop is complete, we could actually log the I value, and the I value is 5. So it could get very confusing when you have multiple I variables in different places in your code, and you don't know why you have a bug in your application. Okay, so the important thing to notice here is variable and function declarations are hoisted, but initializations are not. But we have the concept of block scoping in ES6. The let and const keywords can be used. Let is a declaration with block scope. So I could let name equals Steve, and if true, let name equals John. I could log name inside the block of the if, and I could log the name in global scope, and the names will be different. We also have function block scoping. I could put a function inside a left paren, right paren, and you could be inside the data function, but if you go to call that function outside the block, it's not defined. But in ES5, you would actually log inside find data function because the function is hoisted. But this makes us gives us the ability to write safer code and understand how to define functions in a particular scope and have more control of our function block scope. Okay, arrow function expressions. It's a shorter notation for anonymous functions. It adds lexical scope for the this variable. Using anonymous functions and expressions can be simplified by using arrow functions. So suppose I have a var get movie, and I set it equal to left paren, right arrow. I'm going to call it a fat arrow, and then define a string alien covenant. So notice, first of all, we don't have a function argument, a name. We don't have a left curly bracket, a right curly bracket. If it's a one-line function, you could pretty much, the notation is very simplified. So if you log that get movie, you will basically see alien covenant logged. However, if you have more than one line in the arrow function expression, you need the left curly bracket, the right curly bracket. So in the case of get uppercase movie, I add left curly bracket and right curly bracket, and I define the string to uppercase, and I return it. Then if I log that, it'll be the movie in uppercase. Also, if you have a function called getCost and it only has one argument, you don't need the left paren and the right paren. You could just define it to be price plus times 0.06, and it simplifies the syntax. So the arrow function expressions can be passed to the arrays functions such as reduce and filter, and you'll see this quite a bit. Even in the usage of observables, arrow function expressions can simplify your code dramatically. So here's a case where we have a quantity array 2, 4, 6, 8, and we say the sum of the array elements, and we take the quantity array and we reduce it using an arrow function. The arrow function a comma b, fat arrow a plus b, would add all the elements of the array using that particular function. The array.reduce will take a function which tells you what to do to reduce the array to a single element, so we are giving it that function. So the sum of the array elements equals 20. The other thing you could do is you could filter elements and find out which elements adhere to the filter. So we'd have a quantity array dot filter, and we pass in an arrow function expression, value fat arrow value mod 2, and we get all the elements that are mod 2. And like I said, what you'll see is when you use observables, you make web service calls, you run your arrays through maps, reduce, filter, etc. The arrow function expression also removes confusion with this pointer. ES6 passes a correct reference to the arrow function, so this points to the correct object. So for example, suppose we have a price quote. We pass an item, and we say this dot item is equal to item. Now we call the set interval function, which is in some sense simulating an asynchronous call, and it's passing the this dot item. Well, this is going to eventually be picked up by the event loop and executed in the stack. So this within the arrow operator for ES6 will point to the correct object and the correct item of this object, whereas it could possibly point to the window object or any other object, and this makes our code, asynchronous code, much more robust. So this arrow function uses the enclosing context when referencing this dot item. So for example, if I instantiated a price quote with necklace, that function set interval would be called, and eventually the item necklace would be logged correctly. So the log statement would be the price for the item necklace is some random number. Just an example. Rest and spread operators. ES5 arguments object can be accessed locally in any function. And so whenever we need to know how many arguments were passed or whatever, we reference this arguments object. Well, in ES6 we can use the rest and the spread operators, which is really a triple dot notation along with using collections. So suppose we take a look at a rest example. We use rest to pass a variable number of arguments to a function. So for example, suppose I had a function. I implement it with a dot 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 people. The goal is to call the function with an argument, county, and a list of a variable number of people. So this could be Pete and John, Pete, John, Joe, Pete, Mary, Joe, John, John, whatever. The call would still work. So the way I do that is I use the rest operator, and I have this dot 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 notation with this people array, or let's say a collection. And what I do is I find the length of the array, I take the total income and the average income variables, I set them to 0, and then I take the people collection, and for each element in that collection, I invoke a function, person. And what I do is I do the total income is equal to total income plus the income of the person. And so I have the average income is the total income over the number of people. I return that. So let's assume this is pseudocode for the moment. What I'm really demonstrating here is I have different types of calls I might want to make. One with one person, one with 3 people, one with any number of people. And I want to calculate the average income for all different types of calls. So what I do is I use this dot 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 people notation, and that passes a collection into the array which I can then do nice operations on the collection to implement my function. The spread operator is a little bit different. It really takes a collection and spreads it as you make the call. And I get these two confused a little bit, but once you realize spread is taking the collection and spreading it across a fine grain of arguments, and just try to remember that, then the spread is pretty straightforward. It's used to turn an array into a list of arguments. So suppose I have a function which has a category and person 1, person 2, person 3. I could have an array of people which corresponds of persons, and I could basically call this function average with a category and a rest operator and a collection. So in this case here, I'm looking at the three person 1, person 2, and person 3's weight. I divide by 3, I return the average. So if I want to call that, I could basically instantiate 3 of type person with different weights. I could create an array of people. I could call the average function with the category, which is weight, and the people. If this category was height, I can implement something with height. So these are very useful functions for coding in JavaScript when you're building Angular applications. Okay, generators. Execution can be paused and resumed multiple times. It can yield control to the calling script, which runs on the same thread. So inside the function call, the keyword yield, and you call the keyword yield, and the execution goes back to the calling script. By calling the script's function next, you could resume the function. So first of all, a function which has an asterisk before the function name is a generator. You put a yield on it, and when you instantiate the function, it creates a generator. When you invoke the first next, it begins execution, so it logs begin log info. When you invoke it again, it continue processing info. Now, when I first saw this, I was like, well, this is nice, but I need more control, and you do get more control. Okay, yield can return a value, so you could run pieces of your application getting values, and when the value reaches a certain threshold, you can use that value. So here's a generator called getPrice, and while true, we yield a random number. So this is going to get called over and over and over again. Each time the random number is going to get executed every time we invoke the next operator. So we use getPrice to generate the iterator. We define a constant, limit price is 25. We let price equals 30. And while the price is greater than limit price, that is, while the price is greater than 25, get me the next value, get me the next value. I'm watching the price of this item. And then if it's not greater than $25, that means it's less than or equal to $25. I will get a handle on the price, and I would purchase the item. So notice here and here, this yield, I could be calling web services looking at stock prices or something, and when a stock price is below 25, I could automatically purchase. So it's a good way to develop automated asynchronous systems and be able to invoke different parts of your function, or even the same part of your function over and over and over again. Okay, destructuring takes objects or collections apart using an assignment syntax. Matching patterns are used to extract data from an object's properties or an array in a simple expression. So you really need a matching pattern that matches to the object or the array. So for example, here's a getItem function. You have an ID and you have a description, and the function returns this JSON object. In ES5, you'd have to get the item, get the ID, get the description, and create a JSON object, or whatever you might do with it. In ES6, you get the item, and a destructuring fills the ID variable and the description variable. So you can now use those two variables in your code. Now, when we say matching pattern, we mean this ID has to match this ID, this description has to match this description, or else your variable would be undefined and you'd be using an improper variable value. Okay, so suppose you had a getItem and you had an ID of 23 and a description equal to iPhone. Well, you can get the item and you could say, well, I want to get the ID, but I want to call it identity. So you can alias the variable in the object. So when you log the ID is equal to identity and has the description, these values will be well defined. It'll basically output the ID is 23 and has description iPhone. But if you don't do that, identity will be undefined. You'll get an output which is undefined. Use square brackets, and when destructing arrays, you use square brackets, and variables match the indices. So here I have let company 1, comma company 2 equals these two company names, SOA Consulting Services and FedEx. When I do log company 1 is equal to company 1 and company 2 is equal to company 2, I output the right output. Company 1 is logged as SOACS and company 2 is logged as FedEx. If I don't need the first variable, I could just leave it out. Company 2 will still be logged correctly. Okay, and here's something really nice. You could destructure arrays. So suppose you have an array and you let users equal the array. You could also say let user 1 and user 2 and use the triple dot notation other users to create a collection of the remaining users. So in this case here, user 1 would be Steve, user 2 would be John, and other users would be Anne and Mary. And this is really nice syntax if you want to take a, because I know there's lots of times I like listing even like the months of the year, and we could use that, but getting them in an array this easily is very, very nice. Okay, so iterating. Okay, so for each iterates through an array. For in iterates over property names of arrays and collections, and for of iterates over data regardless. So let's suppose you have an odd array, 3, 7, and 11, and you define a label property called odd numbers. Then you could take the odd array and for each one, use a fat arrow function expression to take each element and log it. And basically, what you'll see is output 3, 7, 11. In other words, it doesn't interrogate all the properties. It looks at the array values. And there's no break possible with the for each. Now, for n is going to do something a little different. It's going to look at the property name, so it'll catch this label that we defined. So when for n, you say for let e in the odd array console e, and what you'll see is it iterates over the property names. So you'll see the outputs 3, 7, 11 in odd numbers. And then the for of, you can actually break out of it. So suppose you're iterating, you have a for let e of odd array console log e. If e is 7, you break. The output would be 3 and 7. And if you didn't break, you'd see 3, 7, 11. You wouldn't see the property. So now we talk about classes and inheritance. There's keywords, class and extend. So if you have a product with a constructor takes an argument price and it defines this dot price equal to price. It implicitly defined a member variable called price. And if you call get price, you could return this dot price. So this is this class you could actually instantiate an object with the class by passing in a single parameter. But let's move forward and look at inheritance. Here I have a class guitar which extends product. Now if I want to create a guitar, I say it's equal to new guitar 1500. And 1500 would be passed to the constructor of the superclass, which is product. So now if I get price, there's different ways I could log that. I could log it in a string. I could log guitar.price. I could just list the price. Okay, in static variables, if you use static variables, use TypeScript. There's more support for static variables. But with a class, let's say it's item, I could define a static variable outside the class, item.counter equals 0. And if I instantiate a new item 1, and I increase the counter, log that counter, instantiate a new item 2, increment that counter, log that counter, you'll see that the counter is keeping track of the objects I'm instantiating. Okay, so here's a little blurb about getters and setters in classes and inheritance. So if you have, let's suppose you have a var person, you have an object, and that is income is 0, and you have a set income which defines this dot income equal to income, and you have a get income which just returns this dot income. Then basically what you could do is you could take person.income equals 50,000, and that would invoke the set income function. And if you log person.income, that would invoke the get income function. So you'd see an output of income equals 50,000. So the dot notation is used for invoking get and set methods. And of course, there's methods, And methods, you don't have to put the function keyword in front of it. So here, calculate tax returns this dot income times 0.25. So once again, you could define the income of the person to be 100,000, and you could log, if the person's income is, and that person, that income would do a get income on person, and then you could log comma space their tax is, and do a $ curly bracket person dot calc tax right curly bracket, and basically you would log the output. If person income is 100,000, comma their tax is 25,000. Thank you, IRS. Okay, so the function keyword is not needed in function calls. Okay, there's a super keyword. Suppose I have a class, and there's a constructor income, which defines the income attribute of person, and I have calculate bonus, which returns 0.10. I could define an employee class which extends person, and my constructor, which has the income and the state parameters, can call a superfunction income. So it could set the income attribute using the superclass constructor, and then I could define the state in a derived object. So my calculate bonus, if state is New York, I could return 0.12, else return super.calculate bonus. So here's where the calculate bonus in the derived class is either returning its own implementation of the tax, or it's calling this the superclass calc bonus function to return 10. So a superclass can invoke a constructor of a subclass can invoke a constructor of the superclass, and the super keyword can be used to invoke functions in the parent class. Okay, promises. Promises are asynchronous processing. ES5 is callback hell. We know what that is. ES6 is this thing called promises, and eliminates unnecessary nesting and makes code more readable. It waits and listens for results of asynchronous operation and notifies you of success or failure. Promise object is future result of the operation, and it has three possible states. Either it's successfully completed, in which case it's fulfilled, it's rejected, which means it failed and returned an error, or it's pending, it's still in progress. For example, suppose we have a function called getProducts, and it returns a new promise. The promise takes a function with a resolve and reject, and we call a setTimeout function to simulate async. But the bottom line is, if it's true, we resolve it and return a value, else we reject it and return an error. So the function is asynchronously, the setTimeout is a browser API call. So it invokes the function asynchronously, and the code gets executed by the event loop that pulls it off the queue and executes it in the stack, and so you'll see the result or the rejection or the state of the promise after you call getProducts. So here's how you implement the asynchronous processing. You let promise equal getProducts. At that point, you're logging something right after that, invoke getProducts and waiting for results. That will get logged immediately afterwards. But meanwhile, the promise getProducts has invoked an asynchronous call. And when the result comes back, the products will come back and you're going to log them. Or an error will come back and log them. So it's a clean notation and a clean syntax, but based on my experience, it still gets frantic with embedded web service calls, etc. So I still think there's some things which Node.js had which were better, like the async module, and I hear they're leaning more towards promises now. And if you can get away with something simple, calling 2, 3, 4, 5 web services with promises, and it's not a big mess, then you do it. But the thing about the async module is you could do things synchronously, asynchronously, and do a lot of other things. So take a look at the async module in Node.js and ask yourself, why don't we have something like that in Angular? Because, well, the real reason is because a lot of logic should be in the middle tier with nodes. So if you find yourself calling many web services that depend on each other in the front end, it's poor design, but sometimes you have no choice. Okay, so now we're going to end this with modules. Modules are a file with JavaScript code that provides a public API that can be imported so that other code can use it. It usually implements a categorized set of functionality needed by the app. It makes your code more organized, more reusable. It makes your applications more modular, so developers can be working on different modules. It externalizes or internalizes resources. They load in browser on an as-need basis. It's just good stuff. Now, there are several different JavaScript module loaders, and some of them are for server-side, like CommonJS. Some of them, the AMD is the standard for browser applications, and Require.js implements AMD standard and loads on demand. System.js is a very one of the better loaders, because you could pretty much config anything you want to do and look at a big, large JavaScript application and do whatever you want to do, however you want to do it. It's more sophisticated, more difficult to use, but it is one of the better loaders. Okay, so ES6 modules are part of the language, so there's no more third-party libraries needed. If browsers do not support ES6 modules natively, we can use polyfills to let you use JavaScript modules. And what those polyfills are, sometimes it's hard to tell. We don't care. We just need things loaded properly in the browser. We do want control, though, if we need it. But right now we use WebStorm, we use Webpack, and we're developing in developer mode, and there's just a lot of work to do, and there's a lot of stuff. So Webpack takes care of everything, and you can configure Webpack to do different things, but I would recommend leaving it alone. Okay, so basically we said a module is a file with JavaScript in it. So really the only thing, there's nothing that really labels it a module. The thing that makes it into a module is these keywords, imports and exports. So in a script you can use the import and export keywords, and it will turn the file into an ES6 module. For example, suppose I have a file, I have a variable, it's not exported, and I have a class, it is exported. Okay, and then I take that thing and I say, hey John, you could use this. John imports that, and he could use my exported class, but he cannot use my variable because it's not exported. Okay, so the import, you declare what you need to use variables and functions defined in another file. With exports, you declare variables, functions, or classes that the module should expose to other scripts that are only available via the import. So variables, functions, and classes that are not exported remain encapsulated in the module. Declarations in the module are local and never become part of the global namespace. This differentiates it from a regular JavaScript file. For example, when you put a script in your file, it makes the code global context. Okay, so there's two types of modules named, two types of export usage in a module. There's named and default. Named, you use the export keyword in front of classes, functions, and variables, and when a script imports named exported module members, their names must be placed in curly brackets. So here, I'm importing county code and calc average weight from a module, and that module has exported country code, calculate weight, and there's also a function here, find average. Now, since I've used curly brackets, and these use exports, and these have names, I could put these in curly brackets and use them in my code once I import it. So here I say, if country code is 3, do country, it's actually county specific implementation, and then also call calculate average weight. But I can't invoke this function. I don't have access to it. It's in this file. So what you'll see is when you have files and stuff, and the IDE will tell you, I can't find this function, you have to go into the file and make sure it's exported if you're importing it from the file. Okay, here's the default is an anonymous export, and another module can give it another name in its import statement. So suppose I have a function that does something, doesn't have a name, I export it as default. So now I import calculate average without using the curly brackets from the example. And here I could call the function with my alias name. Or I could take county code and give it an alias name from the example. Now county code is exported from the example module, and so I'm redefining it as county tax code, and now I could use county tax code in my application. Okay, so that's it. Thank you for joining us, and we'll follow up with a code tutorial.